Hello YouTube! Welcome to episode 7 of my Digital Aquarium Controller series. For today's work, we'll wire up a DHT11 sensor into the controller and program it to give humidity and dew point readings. Humidity can be an issue for a fish room. If it is too dry, water rapidly evaporates from the tanks. But if it gets too humid, you may get condensation, causing mold and wreaking havoc on your electronics. To best control the environment, I need data. This is how I'll get it. The DHT11 is a temperature and humidity sensor. There are many others in the market now that are better or more robust, some even reading barometric pressure. However, this sensor is well established and inexpensive, and it's plenty good enough for the task. The wiring is simple. It's similar to the DS18B20. It has power, ground, and a single data line. The fourth pin isn't connected. It can be powered by anywhere from 3 to 5 volts, but I'll be using 5. A 10 kilo ohm resistor is used to pull up the data line. This does not use the one-wire bus, so it'll need its own pin on the Arduino. To place this a bit away from the tank, I measured and cut 11 feet of Cat3. I'll only use 3 of the wires for this. On one end, I'll add a Molex connector to connect the cable to the controller. On the other, I'll add a standard female pin header so that the sensor can be plugged into. That way it can easily be changed if needed. I crimped on the pins, but before assembling the header, I want to solder a 10K resistor between the signal and the power line. I'm adding it directly at the connector to add stability for the long cable run. Once the soldering is done, I slip a large piece of heat shrink on and shrink it down. Okay, before hooking this up to my system, and to give you all a simple test example, let's give it a quick run on the Uno. I can use the pin socket up like a breadboard, so I put some jumpers in the 5 volt and ground, and the signal line goes to pin 8. Now we're ready to test. The library I use is called DHT. If you search in the library manager, it's the first one that comes up. There are many sample sketches that you can play there. However, after tinkering for a while, I did encounter several glitches in the various sample sketches. So here's my own, debugged and down to basics. A link will be in the description. First, I define the DHT library, and that we'll be using pin 8 on the Uno. You set the type of DHT to 11, if that's the type you're using. The notes have some instructions for the wiring if needed. In the setup routine, we start the sensor. Then in the loop, we run the read my DHT routine. This is the main routine for the sketch. It gathers the data and outputs it to the serial. Humidity is called from the DHT library and set to a variable. The temp in Fahrenheit is done the same way. There are notes for Celsius if you need to use that, but the sensor is a bit slow, so it's better to pull one and then do the math to convert to the other if needed. We do a quick error check to make sure that we got data from the sensor, and then we use the DHT library to compute the heat index and set that to a variable. Then everything's dumped out to the serial port. The last output of serial is the dew point, which calls the final routine. The dew point routine just does a close approximation based on a formula I grabbed off Wikipedia. You can see it here. It may not be accurate below 50% humidity, but that shouldn't be a problem in my fish room. Now we upload this to the board and open the serial monitor to see the results. You can see that every 2 seconds the sensor is returning the temperature and the humidity, which is then used to calculate the heat index and dew point. Everything is in order here. Alright, now that we've tested the sensor and some basic code, let's add it to the main project. In my main tank controller sketch, I add the library and pin definition, using pin 49 on the Mega. We define the type as 11 and initialize the library just as before. I add some space to my temperature array to store the temperature, humidity, and dew point readings that we'll gather from the sensor. Start the sensor in the setup routine. Then I copy over my DHT routine from the sample we just looked at. A few modifications. I remove the Celsius computation since I won't need it. And the data is read into the global array variable instead of into local variables. Also, since that dew point calculation was so simple, I added it directly to the function here, other than calling a second function. Then, up in the report temp function, which is set up to run once a minute, I call the read my DHT function and output the results to serial along with the readings from the DS18B20 thermometers. This serial port will later be redirected to the Pi, but for now, we can test it on the serial monitor. Now looking at the serial monitor, you can see the data coming through just as expected. Getting that data back is a double confirmation that today is a nice day. I hope you found this useful. If you like this, please click like and subscribe to see more. And until next time, thanks for watching.